All right, welcome back, everyone. Thanks so much to our first moderated panel. I thank you so much for the organizers and the sponsors for inviting me to this fantastic event. I'm delighted to moderate a fantastic panel which cuts across industry, academia, and one of the top nonprofit research institutions in the energy space. Real quickly about me, I'm David Brown. I'm a faculty member at Fuqua right here, so this was particularly convenient for me. I'm in the decision sciences area, so I do a lot of optimization, data analytics. I teach those ideas, and I'm doing work as part of the GRACE project that Dahlia is leading in the energy space, working on things like unit commitment problems. I'm also the faculty director of Fuqua's EDGE Center, Energy Development and Global Environment. So it's a real treat for me to be here. So what we're going to do is have our three speakers present each about 15 minutes each, and then we'll open this up to Q&A, and I'm really excited to see what kind of questions we get here. Okay, so I'm going to start here with Shawn Lackey, who's the Director of Generation Solutions at Duke Energy, and he leads Duke Energy's technology and data products, portfolio and services for Duke Energy's generation organization, including renewables, nuclear energy trading, and environmental health and safety. He has served in leadership roles within Duke's information technology organization that include enterprise data management, data and analytics, enterprise architecture, finance, and technology and data strategy. At previous organizations, he worked on smart grid initiatives, telecommunications, and served as a software consultant supporting applications in the energy, biomedical, and manufacturing sectors. He has a bachelor's degree in computer science from North Carolina State University, and there you go. And just in full disclosure, Shawn, the project that Dahlia is leading that I'm part of, Duke Energy is our industry partner, so at some point we're going to back you into a corner and pick your brain and get your thoughts. So delighted to have you here today and learn from you. So thanks so much, Shawn. The floor is yours.
Thank you, David. I am very pleased to be here today and to represent Duke Energy. My grandfather is probably smiling down on me. He was a big Duke fan, grew up around 9th Street, actually crawled under the fence to go to the Rose Bowl here way back when he was a kid, and then went off with Terry Sanford to Europe. So I know he's smiling down on me, and so I'm really pleased to be here. Great introduction. I won't go into that any further. I mean, that was should have thought about that when I wrote it up. But let's today what I want to talk to you about is Duke Energy's our transformation, our digital transformation, and how we've used data, analytics, and artificial intelligence to begin a journey. And I'll talk to you about what that journey is. So let's see. There we go. This is the obligatory Duke Energy slide that I have to show you. Basically over 8 million electrical customers and 1.6 million gas customers. We are, as of yesterday, pretty much a purely regulated vertical utility. So that means that we basically generate the electrons and we deliver them to your house. We actually had a big sale of a big part of our commercial business yesterday, and so I was out there taking calls about that just before this meeting. So really have a great story to tell, and we learned a lot from that commercial business. It was all about renewables, but we are very excited about where we're getting ready to go. So let's talk about that journey. So about 5-6 years ago, we announced that our strategy was to be net zero emissions by 2050. That's a big story and a big strategy to say for a company like ours. It's over 100 years old. And so our plan is to, basically get off of coal, and I'll tell you that story in just a moment, by 2035, and then to really transition our generation over to non-emitting sources between now and 2050. And at the end of it, we call it net zero. So that's going to take a lot of technology, both on the operational technology side, as well as over on the information and the artificial intelligence side. So to dive a little deeper about that, there's a few words on this slide and some maps, but really there in the middle, that's the one I want to talk about. This is the transition and the disruption that we're going through. And I was driving in this morning. I was listening to about the labor situation up in the U.S. car manufacturers. That sounds like they're getting close to to closing that deal. But a lot of that is driven by the disruption that's going on, right? I mean, they're moving from combustion engines to battery-powered cars, and that's going to be a big change for them. We're under a similar disruption and transformation, and it began back really towards 2005. If you sit there and you look at basically the fonts are probably pretty small, but down there in the bottom left corner, you see that gray spot. Looks like a hockey stick. That is our coal portion of our portfolio. Back then, it was about over 50% of our portfolio, and we brought it down below 20, and by 2035, we'll shut down all of our coal plants. That is the transition began, and as you can see, we've been building out gas turbine plants. That's that Carolina blue that you see there. And the reason that we are using that in our portfolio is because it's dispatchable, and it is less emitting. It still emits carbon, okay, admittedly, but it doesn't have the mercury, the NOx, the SOx, and some of the other bad stuff. I support the nuclear generation unit as well, and if you talk to those guys, that's more that Duke blue there, they'll tell you they were the original gangsters of net zero, right? Because they don't emit any carbon at all. So nuclear will continue to be part of the portfolio, but the real transition's starting right now, and it's that green up at the very top, and we will be building out dozens and dozens of solar and battery sites over the next decade. And I think we have about 20 in the pipeline just this year and next year. And that will continue, as you can see, the growth. That will be how we begin the transition. And then that darker green area there that you see, that's what we call ZELFers. Those are zero emitting load following sources. So this is new technology. And as you can tell, that's kind of more out into the 2030s. And the reason is because there's still a lot of work to do in the research and development. These are things like how do we leverage hydrogen as a fuel? There's small module nuclear that will be introduced. We'll be looking at putting offshore wind off the coast of Wilmington. As a matter of fact, I was actually talking to one of the folks on that team, and he was showing me pictures of what that would look like, off the coast of Southport and Oak Island. That will begin in 2035, but really the thing and the challenge is, was there anybody from around here that was around on Christmas Eve of this past Christmas? Did anybody lose their power? Well, good. Because we did on Christmas Eve. If you guys remember and you lived here in the Carolinas, it was cold. It was like, I don't know, I think it's 5-10 degrees outside, and we ran out of electrons. We ran out of capacity. Some things froze up. Some of our partners around us didn't deliver on some contracts, and so we had to basically do rolling blackouts. That is not where we want to be. That is not what we do. That's not our reputation. And so we have to be reliable. We have to be always on. And so we've got to be real careful about this transition. All right, so that transition is big. But that's not the only thing that's going to change, right? We're also dealing with a change in our customers, and some of you probably are our customers here. The change in their expectations. They have, just like in other industries, we have to have a connection with them. They're expecting us to be able to give them information in real time, and to be able to provide them with services that they didn't have, like estimating what their bill is going to be at the end of the month, et cetera. There's also, as we talked about, the clean energy transition, and we've got a lot of changes there. But we're also going to be adopting and thinking about how we deliver those products and those services and those applications and that data out to their mobile phones. So really, you got to be thinking about digitizing everything, all the way from the customer all the way out to the edges of your operations. And then in order to get them to begin that transition, because we'll be actually engaging our customers with their electric vehicles, that will introduce something new for us, as well as even creating new products where we might come out to you and say, hey, you've got an electric vehicle. Well, on a cold night, would you mind if we drew some of the power off of that, and we'll make you whole and make it right with you. So there's new products and services that we're going to be rolling out. But again, that reliability is extremely important. We can't have another Christmas Eve like we did this year. You do all that right, and you end up with happy customers. You get happy customers, you get satisfied regulators, okay? And that's very important to us because we are depending on our regulators to back us in this transition that we've got to make, which will be investments of really hundreds of millions of dollars over the next several years. And then at the end of it, we end up being net zero, and that's where everybody wants to be, right? And then hopefully, in the middle of all that, we're able to also provide a return for our stockholders because we do have stockholders. We're a private company, even though we're regulated. So how do you get there? Well, what we've decided to do is adopt digital transformation. And what that means is we are going to digitize everything in our business and really run everything off of data, really focus in on our customers and create fantastic user experiences for both our customers, for you, as well as for our digital employees that will be working internally. To do that, we've got to adopt a lot of new technology, APIs, real-time data. We're moving to what we call a data fabric. We have a data strategy that really focuses on how we'll roll out that data fabric. And then, of course, artificial intelligence and machine learning, as well as generative AI, will be part of our future as well. You do all that right, you end up with, as a digital utility moving forward, we're not just an electric company anymore, we're actually a digital company. So how do you do that? As far as the technology, well, there's a lot of technology involved. I won't go into all the technology we are adopting. Obviously, cloud is absolutely essential. You can't afford to provide and develop the products and services without cloud because it's just too expensive, especially if you start getting into the artificial intelligence and the generative AI aspects. We are going to have to depend. And we have a partnership with AWS, and we've actually been building on AWS for several years, but kind of formalized that in the last couple of years. But what I'd like to also introduce is the idea of transformation is not just about the technology. Transformation is changing the way that you solve problems. And so as I go through these use cases, I'll talk about what was the problem that we were trying to solve. And that's more of adopting what we call a transformation operating model. That is human-centric design using design thinking. So stepping back and using techniques that are taught in design schools to focus on the problem. And we always say fall in love with the problem, not the solution. So many of our business executives see a shiny object and go chasing off after it, thinking that's where they're going to get the value, and the vendors love that, right? Sorry if you're a vendor in the world. So, that's one part. We also know that we need to fail fast. So we've got to, and you hear that a lot, right, in innovation. We've tried all kinds of ways to fail, to learn innovation and do it. One way that we have adopted is from the venture capital industry, which is something we call metered funding. So give you a little bit of money, go out there, try something out, come back and show us. Doesn't work, kill it. Take that capital, go move it somewhere else where it can be useful. All right, so there's those two things. And then we have to deliver value fast. When I go to my nuclear leadership and they complain about how slow we are with getting out a product, and I say, well, we're going to move to a more agile technique, and we're going to half the time where you're going to start to see value. That means something to them. And then there's the technology, the cloud, the artificial intelligence, what we call the modern architecture. Everything's got to be automated. You got to be able to release everything very quickly, test it very quickly, and roll it out. And then you've got to be able to reach out to the edge. That's where the Internet of Things plays in, and you'll see some of that in some of these use cases. So let's talk about those use cases. Let's start with this one. I've got a couple of use cases. I'm from the generation side, so I'll give you a couple from a solar area, and then we'll talk a bit about a grid problem that we've had. The first problem is with solar panels. So if you run a large number of sites, like we do, hundreds of sites, you have hundreds of thousands of solar panels, all from different manufacturers, et cetera. What we started to begin to find was that some solar panels work better than others from different manufacturers. We were finding that we were having a lot of solar panels that were beginning to fail, and they were failing before the warranty. So the manufacturer owed us money or owed us another solar panel. But it's so intensive to go out into the field and inspect every solar panel to see which ones are right and which ones are not. So what we decided to do was use drones, use vision modeling to take the images from the drones and feed it in, and maybe somebody in this room can tell me how it works, but using the frequencies that they're seeing off of the light, like we can tell you which solar panel is bad and which one is good. Also be able to connect the dots between where that solar panel is and geolocate it, so I can then send that back to and find out, okay, what's the manufacturer, when did we buy it, do they owe us any money, and then also dispatch a work order automatically so that we can get a tech out there to replace that solar panel. All of this was built, I think early on, we did this initially in-house on an internal Hadoop database. I wasn't supposed to talk about the technology, was I? But anyway, but we did this internally, and we're actually getting ready to move this out and migrate this out to AWS. Okay, so the next example, this one's more of a Internet of Things problem, and this was what we call smart. Similar problem, but more at a higher level. These solar fields are not only made up of panels, there's a lot of other equipment that is on them, inverters, et cetera. And so we found that if you take that some fields were more performative than others. And so which ones are, which ones aren't, what part of the field do you need to go fix, what inverters do you need to go replace. So we use Internet of Things to grab the data off the edge, feed it into a model. Again, and as I heard earlier today, how do you present the data? We built an application so it's very easy to take a look at that and understand where you need to go and what you need to go do. And then finally, there's this use case that we have. This is one I don't think a lot of people recognize sometimes. It's a very old problem, which is understanding where your meter is and connecting it up to where the transformer is, or where your meter is and what phase it is on the circuit. So again, using drones, using vision modeling, we're able to geolocate where the transformers are. We've already got the location of where your meters are because we're connected to them, and then create a model that scores that and begins to improve the data quality. And what's the problem there? Well, if I don't know which meter is on which circuit, I'm not going to be able to communicate to you when we do have an outage. And so what we found is our customers really appreciate it whenever we can communicate to them during an outage and give them a restoration time. I'll just say one more time. I've got a little more, I guess I'm out of time, but I did want to talk about this real quick. This is our generative AI approach. We are just beginning on this path. We've already been doing proofs of concepts with generative AI, which is, ChatGPT is the example that everybody seems to know. It just came out about a year ago, or maybe not even that far. So one thing, we have our vendors coming in. You'd think they'd been doing it since the Reagan administration, but it really is. We all kind of are in the same place with this. I think Joe said earlier, he had a lot of examples of where they see where they're going to use AI and generative AI. A lot of the same use cases, developing code, et cetera. We've got a use case that we just worked out where one thing in our nuclear industry that we do is you have to go change a pump. You're very highly regulated. You got to follow everything that's in the manual. The manual might be 100 or 200 pages, right? You just need to do one little thing about that pump, and you got to go read this huge manual. So what if you feed that in to using Bedrock on AWS, and you ask it a question, you build a prompt, ask it a question, hey, I just need to change this breaker, and it comes out and answers it for you, and does it very quickly. We think we can really reduce a lot of labor out in the field by introducing things like generative AI and those kinds of use cases. But anybody watch that 60 Minutes segment on AI a few weeks ago? I don't know if you did. If you didn't, go out and YouTube it. I was having a lot of trouble getting through to my executives, the business executives, and I just sent them a link. Said, go watch this. And basically, the thing that got them, everything from Armageddon and everything, that discussion, that got their attention. But if you go out there and look at, I'm a 70s, 80s kid, right? So Rock'em Sock'em Robots. They had a couple of robots that were about that tall, looked like Rock'em Sock'em Robots. And they were playing soccer, on a little small field. And they were talking about how they did this. And the 60 Minutes interviewer said, well, how'd you teach them to do that? And the answer was, we didn't. They taught themselves. You show that to an executive, and it gets their attention, all right? So I encourage anybody to get out there and take a look at it. So we've got to be thinking about the legal aspects, the human resources impacts, compliance, ethics, because these generative AI models, based on the data that you feed them, they hallucinate. You can introduce bias into the model, which introduce all kinds of HR problems and ethics problems and legal problems. We've got to be out there communicating, getting out in front of our executives, in front of our employees. You got to be thinking about the cost benefit, because these AI services are not cheap. And then we'll continue to do R&D and develop standards. And finally, governance is important. We got to decide when we use them, and is it the right use case to use them, using our stakeholders from legal, HR, and across the company. So just wanted to leave you with that, and look forward to your questions.